Now, also in the book, besides maps, you're going to see lots of photographs and lots of information about temperatures and all kinds of things, that data, if you will. And more today, it's what we call remotely sensed data, and meaning that we rely on things like satellites to get. I don't physically have to go, to these places to get the temperature. The satellite will do it for me, and I can get the information for that. So that's what remote sensing is, and it's all kinds. It's not just temperature; it's land cover. It's all kinds of things, and I'll show you some examples here as we go through. Now, this is the Rift Valley in Africa, which we'll talk about later in another chapter. It's got lots of volcanoes. Now, if I'm just in an airplane or the satellite looking down, here's the smoke from the volcano. Notice how it kind of covers everything up. But if I use radar will penetrate down to the ground, so I see what's directly underneath. And then I can assign different land covers, different color values, if you will. And again, people go on and get their PhDs and they major, that's all they study is remote sensing. It's a big science. But, again, if you're interested in that, we teach it at CSUN, come down and become part of our program. And here's, all the different things that are involved in this. The space station, the space shuttle when they had it up, airplanes, even helicopters, high altitude aircraft. They don't have drones on here, but we use drones now a lot. The Landsat satellites, NOAA is National Organization of Oceanic Atmosphere Agency, so that's kind of the thing that keeps track of all this. GOES, I'll show you some examples of GOES satellite photography here in a second. But it sends the signal down, it comes back, then it's received on the Earth's surface. You assign bandwidth to it, certain band lengths are assigned to it, and then you can assign colors if you want, and then it is processed and is displayed as an image on your computer. In theory, it's really easy. It's a little more difficult, of course, in reality. But that's all it is. You send the signal down, get it, send it back to Earth, process it, and bingo, you've got all this information. Surveyors use it all the time. Big industry now, again, is using that. Here's a guy out in the field. This is what it is. It's connecting to, I think up to 5 satellites up here, and so he's reading the exact point where he is down to a resolution of maybe less than 10, 12 inches. So it's highly accurate now. The military used to guard this stuff, but not anymore. You can go to your local Radio Shack and buy it. We put them up in the mountains to collect data on everything from wind speeds to snowfall to temperature. We have actually used them to spy on countries like China to detect sound and motion back in the days of when China was developing its nuclear weapons. We put one up in the mountains, and when China detonated a bomb, this thing detected the sound and the seismic wave, and that told us, how far along China was in its nuclear program. And just looking ahead, you can see the glaciers and so forth here that we'll be looking at. Notice them right here. When I think it's chapter 13, I think is the glacier chapter. This is an example. This is visible. So if I'm up in the satellite looking down it's after midnight on satellite time. So, it's when the satellite took this, it's thinking it's tomorrow. But this is what it looked like. So you're looking at the visible cloud cover, and notice that there isn't much over California. And if you look out in the sky, maybe you'll see this is mostly fog around here. But again, this is an example of remotely sensed data. You're looking at the cloud cover. This is water vapor. So the two are kind of related, basically taken at the same time. Darker means no moisture, white indicates some moisture, blue, and as you get to the purple, so this is your scale. So as you get into these colors, it's much, much more. So you're getting storms down here in central Texas, but again, notice us, there's nothing. No moisture in the air, a little bit up here, but that's contributing to the droughts. And we'll get familiar with why this is later, in later chapters when we study fronts and air masses and so forth. But again, an example of remotely sensed data that's looking only at water vapor, amount of moisture in the air. This is infrared, so here's your storms over here. Let me go back. So you can see the water vapor here. So notice how this kind of correlates right there. And again, nothing here. It's just, this is the temperature. So this is where it's cool. We're looking at clouds. So the clouds, this is cool clouds, warmer clouds. So wherever you have storms, you have more heat energy. Because like I said, remember, moisture has a capacity to store lots of heat energy. But again, an example of remotely sensed data. I'm going to show you two of these. This is from February, 22nd February, looking at sea surface temperatures and land surface temperatures. So this would be cool, this would be warmer. Now, this is important because this is, our winter is ending. So notice here, notice the cool temperatures here and the warmer temperatures here, and this band of clouds right here. This is called the intertropical convergence zone. We'll get into this in a few chapters. But the next slide, watch how all this changes, okay? Here we are in August, today. Well, not today. Yeah, 18 August, today. Notice now, it's the end of our summer. Temperatures are colder here. There's no, see how warm we are up here. Let me go back. Just watch here and here. See? Mostly yellow, light orange, all this purple. Now it's dark orange and red, hardly any purple. This band of clouds has moved up, into the northern hemisphere and now is heading back down, but it's higher in latitude. Again, I'm going to go back, so just watch it right here. So here it's down here. In the next slide, it's going to be up here. And that's because this migrates with the seasons, following the sun. But again, remotely sensed data. Sea surface temperatures, again, from February. And here's the way, if you want to go see them, just click on this. This should be active in your browser, so you can click on that. Not in the movie, but if you go to the PowerPoint or probably not in the PDF, but if you go to PowerPoint, this should be active, and you can go see all these types of things. Okay, then here it is in June, the height of the summer. So where's a good place to look? Right here. Orange or right here. See where it's still blue? Now it's all red, really red here, so temperatures have gone up because the sun is up here now. And again, this is all remotely sensed data, and we can use it to make predictions, into the future for the climate. It's important to look at this. We have satellites directly over Antarctica, which is what this is, and we have ones directly over the North Pole, so we can, keep track of the ice. And again, remotely sensed data. Now, that all is part of what we call Geographic Information Systems, GIS. And what they do is take the spatial characteristics, remember from the first couple slides, and attribute data, like temperature or rainfall or anything, any variable you want, and it combines them. And then you can create different data layers. You can combine physical features, you can combine cultural features, and what you get is a big composite overlay. And I cannot stress how much this is used in everything today. And from marketing, if you want to figure out where to put the next Domino's pizza to where you want your drone to deliver a missile. It uses this, and that's why this industry is so important. And this is just an easy way to look at it. We want to create cat just barked up a hairball. Sorry about that. We want to look at we're looking at the probability for spread of West Nile virus down here, and so you can load data up to get that. This is a land cover map of Washington. Now, how do we get this? Well, all these different layers. I go get just the general, what we call the topographic base, just a flat generic map of Washington. Then I add parcels to it. Your house is on a parcel, your apartment, or whatever. Remember that surveyor, that's what they do. Then zoning, well, it might be set up for residential, might be set up for commercial, or it might be parks or something. Floodplains, can't build on floodplains. Wetlands, can't build on wetlands. Land cover, is it forest, is it desert, is it brush, the soil types. I can combine all that attribute information into one last layer, and that's what I end up with. Something just like that for the whole state. And it has it for, I can zoom in and get it for distinct points, if you will. If I'm looking to build a hotel or something like that, that's how important this is. This is a real simple one, but let's just say in Arivaca town site, I want to build a hotel. Where can I build it? Well, let's lay in the federal property, tan, the streams, the blue, the floodplains, because I can't get insurance. So anything that is this can't build on. Anything that's white, I could build on. So, that's how easy the decision is made. And, we can teach you how to do this, in the very first class that you would take, which I think we're going to start offering at Oxnard in a couple semesters. This is another very simple one. A bunch of rich people live in the Hamptons in Long Island up in New York. They say, well, what happens if the sea level rises 5 feet or 10 feet or 15 feet? How's it, who's it going to affect? Well, population density, pretty low, 0 to 10,000. So not very much there. But average household income. The dark greens are the richest. So notice that it only has to go up 5 feet, and we're grounding high-income housing, houses where rich people live. Then you throw in the average housing value, and again, this is old. You can just add another 0 to this in most of these cases. So again, notice that it went up 5 feet, which is this yellow line. All these rich homes are going to be underwater. Serves them right. Okay, so that's just a real easy example of how GIS and remotely sensed data works. And another one here, add in low birth rate, census tracts, toxic releases, streams, income, and combine the layers. Well, it might tell you, where you get clusters of problem bursts that are related to toxic releases, be it in the water table or the soil or whatever. And notice that they built these homes right here, so these homes have low birth weights, and as it turns out, it's probably related to this. Okay, so that is chapter 1. If you need to go back and you want to look at things a little slower, you can use the PDF or the PowerPoint. Now the PowerPoint, all the links to videos and so forth are active in that, okay? Right, any questions, just email me.